So in this video, we're going to talk about tokenization. OpenAI has this wonderful tokenizer demo that they've built, and you'll see a lot of people reference it, and you can go and say show an example, and it's going to show you how the tokens are being broken up, the actual token count, the underlying characters. It's a great way to visualize this concept. One of the only problems, though, that I found with this is it's only giving you the encodings for the old GPT-3 and codex-based encodings. And so if you're using something like GPT-4, if you're using Turbo, if you're using the new Ada embeddings model, this, while in many cases it may be similar, it's a totally different encoding. So the actual underlying token IDs are going to be different. And depending on what you're doing, in some cases, the token count is also going to be different. And so in this video, what I want to do is teach you how to create your own. So you can go and create your own token visualizer that will give you this breakdown and allow you to go and select whichever encoding you want. So you're not limited to just the GPT-3 and codex. All right, let's get started. So first what we'll do is we'll launch Jupyter Notebooks. So we are going to be using OpenAI's tick token library to handle the actual encodings. So first we'll do a import of tick token. And if you haven't installed it before, you need to do a pip install to tick token to use that. And then we'll define a tokenizer. So we'll say tokenizer equals, and then tick token dot get, and we want get encoding. And then we're going to give it the specific encoding that we want. So for GPT-4 and for Turbo and for the Ada v2, the new encoding is the CL100K_base. There are in some cases some additions. If you were doing things with like ChatML, there are some special tokens that the native CL100K base aren't going to have, but for most use cases, this is going to cover what you want. And then let's go and we'll add some user input so we can go and just type text and have it get tokenized for us. So we'll make a little user input variable, we'll say input. We won't prompt, or we can say enter text here in case you're using the command line. And so then we'll do tokens equals tokenizer.encode. And then we're going to pass our user input that we're going to take to this, and then we'll print out the tokens that we get back. There we go. So we'll enter our text here. We'll say this is an example of tokenization. Okay, so we can see it's splitting this up. And so the important thing to understand with tokens and tokenizations with large language models is the model is never going to actually deal with raw text when the model was trained. And when you're sending input to the model, ultimately it's going to be converted into numbers. So the model is always dealing with just number-based representations that then correspond in some way back to the text. The problem with this is you don't necessarily know, is each one of these a token? How are the spaces being represented? We can also I'll copy in a little bigger portion of text, and we'll run this again. And we'll copy bigger string of text. So this is a longer string of text. You can see again the numbers being generated, but it's not clear, like, is the word enter 3/4. It's what those mappings are. So this is useful, but not quite all that helpful yet. And so if we were to go and then pass this back to, if we said, let's say decode equals tokenizer dot decode, and passed in tokens that we had before, and then said print decode. Let's look at that. So you're going to get back that original text, but it's not that useful because it's not showing us where the token boundaries are. So this, in this case, isn't really going to help us, but it's still useful to know that that method is there. What we'll do, let's define user input again, just for the sake of making things easy. So we'll take input. This time we won't actually have any text in here. It'll just be straight user input. We'll define tokens, and so tokens equals tokenizer.encode, and we're passing that user input to it just to remember how we're doing this. And then let's try this time, instead of doing a straight decode, we'll do decode to bytes. And if we decode to bytes, we'll be able to see the token boundaries. And then there's decode tokens bytes, and we'll pass in tokens here. And then this time we will go and once again print tokens, but then we're also going to go and print our decode, and let's make that spelled correctly. Decode to bytes, and we'll run this. So, and we'll grab that long string of text that we had before. That's just a little bit about how tokenization works and how byte pair encoding works. And so we have our original text that we pasted in. These are the actual representations that the model would see. And then here, and because these are bytes in Python, you see this B prefix here. But you can now see that where different things are getting split up. So you can see tokenization is not one word in this particular encoding in this vocabulary. So it's being split up into token, and then ization is separate. You can also see that spaces are often being appended to the front of a word. So a space doesn't get its own token. Instead, space is a token. Space the is a token. Space process is a token. Space of. This, again, is pretty good, but it's a wall of text. It's very hard to read. It's not really like that nice visualizer that we had before. So at this point, I'm not going to type all this code, but I will copy and paste some code that I wrote previously, and I will quick walk through what we're doing. So I am bringing in ipython.display. If you're not doing Jupyter Notebooks, you could pull this. This is just clearing the output for me to make things a little bit easier after I've entered in text, so we don't have this initial text at the top unless we want to. So we're again going to take user input. We're going to do our encoding based on that user input. We're going to decode to bytes. Then we're going to do a little for loop and go through decode, and we're going to make a list and append the, so basically what we're doing is we're removing, I don't want this B prefix there. So this makes it a little bit, so we get to have where the token boundaries are, but without having it be a byte anymore and have that B where it's kind of hard to read. We'll also grab the character count, we'll grab the length of the encoding, and this stuff, which looks kind of gnarly, is these are ANSI escape codes. And so these are ANSI color codes. And so this is allowing me to go through, and we're going through the token list, and in the same way that we saw with the OpenAI visualizer, we're going to give the token specific colors. So we're going to go through, the first token is going to be assigned the color that matches this color code. Then the second token that appears will get this color code. The third token will get this. The fourth token will get this color, and you'll see this in a second. The fifth will get this, and the sixth will get this. Once we have gone 6 tokens worth of colors, we're then going to loop back and start representing the tokens again with that same color. So the colors are not significant in the sense of, if you see a bunch of tokens that are blue, there's no matching quality, there's no pattern to the quality of them being blue. It really is just to visually offset them, so it's easier for you to see those token boundaries. And if we did them all on the same color, it's not going to be very useful. And also, if we gave every single token a unique color, or each, so like if every time the word the appeared, it got a unique color, once you're doing this to a significantly large enough text, visually it just starts to look awful. So by kind of looping through a very small color palette, it makes it look a little bit less, it's easier for the eye to follow and see. So let's go and we'll run this and show you what this looks like. We'll paste in our larger string of text again on how tokenization works. And that time we pasted in the code. We'll redo that. Let's copy paste failed me. You can see how this works though, that it's actually splitting up the code, how it's doing it, where it's breaking it down. But let's run this one again, and we'll do it with just straight text rather than with code, though it is useful to be able to see how your code is going to be tokenized, because you may see things where from a cost standpoint that certain characters or certain spacing, things that you might want to normalize and pull out to make things more accessible. So now we'll do that text again. And we have a pending input because I tried running it again. We'll just hit enter so it actually runs. There we go. So this is the breakdown. You can now see a little bit. So this again, this is the byte view, but this gives you kind of the color where the split. So you can see space process is a token, space of, space splitting, space the, output, all of that. This is again that byte view, and this is our actually encoding view of what the model's seeing. These are the different representations that it has. We have our total token count and our total character count. This is kind of how the code, when I think about this and I'm breaking it down, this is what I came up with in my head. Once I look at this, then there's ways we can go and really simplify this, make it a little bit cleaner. So I like to show you what's kind of my first stab at something for the code, just so you can see the evolution. But ultimately what I came up with, which is a little bit cleaner, a lot less lines of code, but functionally does the same exact thing, is this. So you can see we've just compressed down some of those loops. We've made it a little bit easier. We've put the color codes, instead of have those kind of individually enumerated, they're here rather than up here. You can see how we were handling that in the if-elif block. But if we run this, we'll get the same thing. We can bring in that text again, and you can certainly paste in whatever text you want to look at. And then you're able to see again. With this right now, we're doing everything as the CL100K base encoding. We don't have to just use the CL100K base encoding. If you're curious what a different, if you happen to be using a specific model and you want to know how the encodings map, you can look at the source code for TikToken. And so here is the actual mapping of the individual encodings. So you can see GPT-4, CL100, Turbo, CL100. But if you were doing like text-embedding-ada-002, that's the P50K base. So if we wanted to go and do something and see the tokenization for text-embedding-ada-002, all we do is sub in E50K base here, and then you're going to get that encoding as you're going through. This is nice, but visually this isn't necessarily as nice as it could be. So what I want to go and show you is how we can go and create our own. So this is kind of my more finalized version and what it looks like. So you have a simple Flask website. We take text input. We can select here which encoding we'd like to have. In the case of CL100K base right now, that is the same as if you selected Turbo or GPT-4. I'm just doing it this way in case someone doesn't know what that mapping is. And same thing technically for text-embedding-ada-002. If you were to look at this, it's using CL100K base for text-embedding-ada-002. But just to make it a little bit more user-friendly, if you haven't memorized, this encoding maps to the specific model. For some of the more common models I expect people to use, I'm just handling that mapping for them. This lets you go, and it also is going to make it a little bit easier to see what is the actual number that associates with a word. So if you mouse over either the word or the number, it's going to do a little expand on it and make it easier to see. You can also, if you want to see the quote boundaries instead of, well, we'll do all of them and we'll tokenize again. If you wanted to see it broken out like this, sometimes that's easier to see that the fact that there is the fact that we have spaces that as part of the byte pair encoding, that these are not just a single word being part of the token, but the space is appended to it. And so space and space output, space text are the true encodings, which is not necessarily as easy to see at this view. But this is a fun thing you can run. This is running online. You can certainly use this if you want to use my version of it that I put out there. But I'm going to post all the source code for this so you can go and dig into this and play around with it yourself if you want to build your own, if you just want to run it locally. There's nothing, because this is pulling from the TikToken library, that library you run totally locally on your machine. So you don't have to have this online. So if you want to be able to check how something's going to tokenize, if it's something that's kind of sensitive, that you wouldn't want traversing the public internet or being seen by a site like mine, then one of the best ways you can do it is just run it locally in Jupyter Notebooks, or you can run a version of this code just on your local PC. Okay, so I'm going to give a quick peek at the code of how this works, but all the code will be in the description if you want to look at it more closely. I will preface with the caveat that I am not a JavaScript developer at all, so I hesitate a little bit sometimes to share code like this, where I think this is an excellent way of building a strong mental model of how tokenization works and have really a concrete example that you can play around with. But I don't want to give an impression that the code is like, this is how you should go and code up this type of app. It is functional. It's a good little proof of concept, but that's really what it is. So we'll launch the project here. Essentially what we're doing, there's nothing that much more complicated than the code that you see right here. So it's still all the same principles, but to do some of the visualizations, we have to have a bit more layers. So the key files to look at are this init.py, and so you're going to see kind of our initial interactions with the tick token library again, just as we had with the other code. You will see some things like this where I found that with certain Unicode characters, when it is encoded, it is split across multiple characters. So then when you try to decode it, things will break if you try to do a one-to-one mapping again. So in this case, we just kind of handle that by doing the replacement character for Unicode. So you will be able to visually see when that's happening. That will sometimes happen with emojis. That will sometimes happen with characters in other languages, but just to be aware of some of the limitations and little bugs I found since we've started. The other thing you want to look at is the index.html, where you see my complete lack of web programming ability. But the meat of the code is the JavaScript here, and then there's also my mess of a CSS file where I'm handling some of the zooming and things. I found let me show you this running. This may be no surprise to a web programmer, but getting this little very simple, when I'm at the index in either the list of encodings or in the list of kind of color visualized, to zoom and do this little expand, getting that to look right was far more confusing to me than I thought it would be. Not that it's super complex, but just getting the right combination of things at the CSS and JavaScript level so it would play nice and wouldn't do weird things with the visualization, or wouldn't do... It really wanted to go with these representations here. I want you to be able to see that spaces are appended to part of the word, and there are a lot of things with HTML and CSS formatting where it really wants to center those words and hide the white space a little bit, whereas in this case I want you to be able to see that white space. And it's also, I'd say it's one of the limitations. When you go to this zoom view, you lose that context of, oh, there's a space in front of texts and outputs, and so that's partially why I have the quote boundaries in here, so you can see this. So it's very, very clear what's ultimately happening there if you want to. And you can certainly enter whatever text you want into this. Sometimes it can be useful to see that, like, the word test and the word test are not going to be the same tokens, which is a little counterintuitive, but because this is test with no space in front of it, and this test is test with a space in front of it, and we'll add the quote boundaries to make that obvious. So even things that would seem like, oh, this is going to be the same token, you find out are different. And it's also helpful to be able to test out assumptions, like there may be, as part of prompt engineering, certain characters that you're using that help you to define a better prompt. So sometimes having separator tokens like a dash, or like having these to offset text can be useful. And it's nice to know that for this encoding, these separator tokens are going to be represented by a single token. So I'm not having each one of, it's not the same as if I did this, where these individual with the space in front of them are all going to be 330. But if I want, I'm not having to use 3 tokens just to create my little separator here that I might go and offset the text. And so it can be helpful to check your assumptions on things like that as well with the encoding that you're doing, to make sure that if you're doing a ton of kind of automated prompt engineering or things that's going to be separating out the text or normalizing the text, that you're actually getting the results you expect, and that the token count is matching up, and that things are doing what you would want them to be doing. And so this you can run completely locally. It doesn't have to talk to the internet at all. You can play around. You can change the underlying encodings. You can certainly as well use this site, though with the caveat of you are talking to the public internet in my site. So if you want to have it tokenize anything that's business confidential to see what that looks like, highly recommend just go and grab the code, run it locally on your machine, and then you can do that safely and learn a little bit more about tokenization. This was just a quick video. Hopefully this code is useful to you. Please do like and subscribe. It does help me. I know it's been a little bit of time since the last video. It's just been very busy, and also I like to take a little bit of time to do some research and come up with some content that I think is useful rather than just the standard, here's 10 things that are fun and exciting about AI or GPT-4 or things like that. So hopefully this is useful to you. Thank you so much.